Yeah, welcome everybody. Thanks for coming. Especially thanks for coming inside on such a lovely day when it's so nice outside. Um, my name's Tjasink. I work for Equal Experts. Have done for about 5 years. Um, I call myself a developer. In my 20 plus years working in software, I've done various different things though. Developer, technical lead, solutions architect, scrum master, development manager. But I think what I enjoy doing the most is being a developer, but having an idea of how all these other things fit together and work together for hopefully successful projects. So I will try to leave some time for questions at the end. Hopefully I won't have to rush through things too quickly. So if you do have any questions, please hang on to them and we'll try to answer them at the end. Thank you. So the title of this talk I did is how much is just enough? So obviously a very sensible question, follow-up question is enough of what? Initially I was going to call it how much is just enough operability, and then I got caught up in all the things I wanted to talk about and want to have arguments about what is and isn't operability, so I just kind of cut it short. So here are the things I'd like to talk about. Things about metrics, alerting, runbooks. I'd like to talk about performance, both sort of testing and scaling out systems, resilience, a bit of planning about it, a bit of implementation, and about making a service supportable. So the thing that inspired me talking about or putting together this talk was I was finding in a product team with a product owner, the product owner is very good at defining, we want an MVP like this. It's going to have this functionality, the customers are going to use it in this way, and then we can incrementally improve it. What the product owner, the product owner is quite an expert at doing that. What the product owner is not necessarily an expert at doing is working out how to blend all of these things in. So I thought it was useful to talk through a few examples I've seen. These were in the context, actually this is the next slide almost, of a build it, run it team. So the context of which these examples take place, a retail organization, we were working as a build it, run it team, or actually 2 or 3 different teams I worked on there. So the team was supporting the service as well as developing it. This was, I don't know, a little bit scary to me the first time I started working this way a while back, but it does mean the development team has quite a good grasp on how their system works. They're seeing it from the inside and the outside, and they're in a good place to make these calls on how much they need to put in. So downtime is costly in this particular scenario. In a retail environment, if your website goes down, you can't sell your products, so you lose money. So we wanted to avoid that. It might sound obvious, as a lot of things in here might sound obvious, but it's worth keeping in mind because this is all about what's the minimum we can do to get up and running and then iterate on it. So downtime is costly. So we take that into account. The requirements change. Again, this might seem obvious, but it's better keeping in mind. As more functionality is added, you may add more complex functionality, which means you need to scale out more because it slows down a bit. Or as more users start to use your service, you might find that it becomes more critical, it becomes more important to prevent it going down. And deploy early and often. This is something we wanted to do. We wanted to be able to iterate quickly. Wanted to get something out early. We wanted to learn from both customer behavior and system behavior by deploying things early. And one of the worst things in this kind of scenario is being stuck in. We developed some functionality. We want to ship it. And now suddenly, we need some metrics. Let's put those in. We need to go through a performance testing cycle. How long is that going to take? A couple of weeks maybe. Not sure. So we wanted to avoid that sort of last-minute trap of we've developed some functionality, we want to deploy it. Now we have all these other things to worry about. We wanted to worry about them early on as well. that is kind of, we want to do something early, we want to balance between doing something early and doing something comprehensive. So, search. This was a project to do with searching, and it was a new search service on a new evolving cloud platform. And we were trying to prove out new ways of working as well. So build it, run it was the operating model we were going with. And this really was a balance because we wanted to get things in early and also prove that this was a good way of operating, and the rest of the organization could trust us and trust other teams in the future to keep doing this. So this is a very, very high-level view of what our search system looked like. We had a search engine in the middle. We had products, prices, and stock coming into an indexer, which would go into the search engine. And then we would have various clients calling the search API, so different mobile clients for different platforms, web client, and with time, other things like customer service searches as well. And this is quite high level. In reality, we had different types of price and different types of stock and other things like review data and ratings and things coming into. And at the bottom, we've got our metrics framework. We've got Prometheus and Grafana. And I was saying this was being deployed onto an evolving cloud platform. There was a platform team who was building this, and we were one of the first teams to deploy onto it. Now, this leads us onto what did we do? The first thing, we installed Prometheus. Now, this is hopefully not something everybody would need to do. It sounds quite heavyweight. But the cloud platform had not yet provided a cloud, a general Prometheus instance for all the teams on the platform to use yet. So while this might not sound like, oh, this was the minimum we could do, it was the minimum we could do in order to actually get something in. We didn't want to be in that position I mentioned where we were waiting around and not putting anything in, and then suddenly thinking, how's the system working? What's it doing? We can't observe this. So we put that in early. And it didn't take very long. One of our developers was really good at doing this, and we were using Kubernetes, and all he had to do was run a couple of pods of which ran Prometheus and Grafana for us, which was nice. So initially, we just went with some out-of-the-box dashboards. We were using Drop Wizard framework, and it had a plugin which would just export certain JVM metrics. These were nice to see. The usual kind of things we had on there, because we had multiple microservices. That was quite a simplified diagram I had up in the beginning, but in reality, we had sort of 4 or 5 of them. And the standard JVM metrics were like CPU usage, memory usage, a lot of things about garbage collection, efficiency of different types of garbage collection, how long does garbage collection take, how many threads are you using, what's the maximum number of threads, et cetera, et cetera. So these were things we thought, okay, we've got dashboards, we've got metrics, this is nice. They don't necessarily tell us what our system is doing, but at least we had the framework in place. So the next thing, well, actually not quite the next thing, we were using Elasticsearch. That was our search engine of choice, and we could get a sort of a standard exporter to get data out of there and put it into Prometheus, so we could have those metrics as well. And the same for cloud resources. We were using databases and pub subtopics and things in the cloud provider, so they were useful metrics for us too. So interesting metrics for us about what our system was really doing were number of search requests coming in and the latency of these. So that was the first thing. We want to serve our customers quickly, and we don't want downtime. So we put those in onto our custom dashboards. At the top, we also wanted to know which products were being indexed, because this was obviously important. You just wanted to serve your customers' data quickly. You want to make sure it's fresh. So we wanted to know when products are being indexed and sort of the reasons for it as well. Whether it was new product data coming in, or whether it was a price update or a stock update or anything like that. So these were our extra things we put onto the top of those dashboards we had. So we had these out-of-the-box dashboards, stuck these new metrics at the top of each of them, and so eventually we had our custom metric at the top. We had our CPU and memory usage, and then all the garbage collection and threads and everything really got shuffled very far down. So these were useful. They gave us information, but they didn't give us an overall view of what was happening in the system. So we put together a headlines dashboard, and onto this we put our most, what we thought were our most useful custom metrics. All the CPU and those kinds of things we didn't put on there to start with, apart from our search engine cluster. This was something hosted externally. This is something we were a little bit more nervous about because we felt like we didn't have so much control over it. So we put that in. And we put in the data we were collating from different sources and indexing. We wanted to know how long we were waiting for that stuff. So we had sort of queue length information. And so this is what it ended up looking like. This is a very lo-fi picture of a screen. Across the top, we've got our search engine metrics. We've got CPU usage, memory usage, number of items in the index. On the right-hand side, we had our queue lengths. And at the bottom, we've got this graph, which was probably the most important thing on here, actually. It's a little bit small here. But it's response time and number of requests coming in. Now, the interesting thing, well, for me here, looking at this, was it's a bit wobbly. I think there was a deployment there. That, as I was saying, we were going to support many different clients calling our search API. We didn't differentiate between them in the beginning here at all. We only had one to start with. We only had a small percentage of total traffic. So we just thought, this is good. This gives us a sense. We don't want to go and put a lot of work into differentiating between different types of requests. The other thing that's not on here actually is indexing data. Here are some examples of what they ended up being later on. This is over the period of a week. You can kind of see the volumes rise and fall. Different colors for different clients. Interesting thing to know. We added that afterwards once we got to a point where we thought it was useful to differentiate, and different types of product data being indexed. So this indexing one, as I said, this wasn't there to start with. We put this there, we added this sort of when we were ramping up our traffic. There's a bit more about performance and stuff, but when we were first going live to even just a small percentage of customers, we had that initial dashboard first. And then the whole thing about, yes, we're serving this many customers, we started to get questions from other parts of the business, you know, have you indexed the products for this for today? And although we could go and look at our other dashboards and see that, it was nice just to stick it on the headlines dashboard as well. And at a glance, in the corner of the office, back in the day when we could do that, it was nice to see. So I think it's also important to think about what didn't we do? Because what are the things we purposely left out and didn't try to go too big on in the beginning? We didn't wait around for the platform-provided version of Prometheus to come along. We wanted to get our metrics in early, so we did that. That's kind of the opposite. We did something extra in order to do something early. Most of what we were trying to do was hold back from throwing loads of stuff in. So we didn't split out the indexing, we didn't display the indexing or split out the traffic to start with. And we mostly stopped using the individual dashboards once the headline dashboard came along. And we made a lot of improvements to that because that was our main view of what was happening in the system. We didn't rarely use the other ones very much. Sorry. So this was about that project I was talking about, search. And then, so this is a related thing, related domain, feeds, data coming in from various sources, of the same sort, really, product, stock, price, a few other things. This was about delivering feeds to third parties, well, consumers. Most of them were third parties. So we'd have several different types of feeds that were generated, and we were sending them to various different consumers. And we wanted a dashboard to understand this. Mostly what we cared about was whether feeds were generated and delivered. And there was a separate microservice that did the generation, separate did the delivery, and collated all the data. So something like this. Again, it looks a bit like the search one, data coming in to a database and then going out. But in this case, we're pushing the data out. So there was a timer. It would kick off the generation, and then would get picked up and delivered. Again, we had our Prometheus and Grafana underneath. So what we came up with was what looked like something like the headline dashboard, because this is something we thought, we know how to do this. Let's go straight for something which gives us a nice overview of the whole thing the system's doing. We didn't go down the route here of having the individual dashboards. At this point, the platform we were using, the platform team had already put something in place to automatically, for each microservice you deployed, give you sort of a golden signals dashboard of CPU usage and memory usage. So, what we have here is feeds generated. That's a 24-hour period. So I have actually blocked out the names of them, but they all have different colors. So just before 7, you can see there's a whole bunch of, a few different types of feeds that get delivered there. And then on an hourly basis throughout the day, it wraps around again, but on an hourly basis throughout the day, often just one feed, sometimes multiple, and then the one below is when they get delivered. So this was, the ones before 7, some of them get delivered to multiple consumers, a couple of the other ones do too, but this gave us some confidence that we were sending out the right feeds at the right times. And that list of numbers is basically a numeric representation of what's in the delivery bit. And in the bottom left-hand corner, you can see data collation. Below this were a load of graphs of the different collators bringing in all the different types of data before they got generated to get delivered. So we didn't look at them that often. They basically looked like that indexing one I showed you before, with different bars of data coming in at different times of day. So I think this was interesting because, well, for me, I was involved in doing it. I thought it was interesting. We just went straight to what's our sort of headline view. We didn't have to sort of go through a bunch of learning steps. We didn't have to install anything up front. So what didn't we do in this case? We didn't have the individual dashboards for our individual microservices. We didn't go into a lot of detail here. Successful generation and delivery was the main thing. We had alerts to tell us if something had gone wrong. We didn't need all of that on that dashboard. Actually, one of the things, it's a bit odd on here, that fat dotted red line at the bottom, if one of those had failed, it would make a big fat red line. We had somebody in our team who was red-green colorblind, so we had to make it dotted as well. But my Grafana skills clearly failed me, and it's persisting even if there aren't any errors. So that was a bit about metrics. I've rushed through that a bit, I feel, but I'll talk a little bit about scaling and performance testing. So we're going back a little bit to that search project I was talking about. So performance requirements do change over the course of most systems' lifetimes. In our case, we had a very slow percentage-wise rise through sort of 1% of customers, and then up eventually to 100% about probably 9 months later. But as soon as we were live to a small amount of customers, we wanted to behave as if, to some degree, we were 100% live, because we wanted other teams and other parts of the organization to trust us and understand that we could support this system. So, so the initial percent was only 1%, and the initial functionality was quite minimal as well. The sort of sorting options we had and things like that, the search, the tuning and stuff was fairly basic. So it was very low volume-wise, but we wanted to prove that we could handle it. So we did some performance testing very early on. I've said week 1 up there. I think previously I've claimed we did it from day 1, but that's like a very conceptual day 1. So it's probably day 4 or 5 in reality, the first week. So at the time, it was a super simple search, but as soon as we had it, we wanted to performance test it, because we were just a bit worried that we have something that's very simple. We do not want to end up in this situation where 1 week before we're going live to the high percentage of customers, suddenly we can't handle the load. We want to be testing it fully the whole way through. So we just put something together, just test it very simply, and then we would know if at some point we added some more functionality, has that particular release slowed it down? Because we're releasing multiple times a day, really. Any one of those things could have caused a drop in performance, and we really wanted to catch that as soon as it happened. So it was easy. So we tested at different percentages. We were going live to 1%. We didn't really need to prove at the time we could handle 100% of load. So we didn't actually try. Because 100% of load would be 100% of Black Friday load, which is way more than 1% of random Tuesday morning load. So we tested scaling for this at different levels. We didn't have auto scaling at the time, and so we thought on our normal level we can have number of customers per second basically searching. Let's test at that level and tune our system accordingly. And then we know what Black Friday will be like. We can test that later on. But because it's manual scaling, we wanted to determine the different levels of doing that. So because we had our performance test in place, we would just change the level, run. We were running in Kubernetes, and we made sure our instances were stateless, and we could, in theory, just keep scaling them out. And we were using cloud resources that would scale automatically to cloud databases and topics. So we got to something like this, the same picture. So index, so we had 3 of those. That didn't really change when you could have 1 user or 1,000 users. The users were searching on this side. So the search engine and we kind of ended up tuning these quite similarly, where our standard level was 3 instances, and a mid-level would be 6, and then our maximum would be 12. So that worked quite neatly. We had a small, medium, and large. We knew what to cater for. We knew that we could scale further if we wanted to. And so our response times, this is latency on the right-hand side here, that's the 95th percentile, the yellow line. It did actually, this is from Black Friday quite early on, just like mid-November all the way through to early January. It did actually work quite well. That spike in the beginning was actually a test, not actual real customers. There's a little bit about resilience I wanted to say, which is related to some of that scaling work. So we wanted to be in a position where we didn't want outages. We wanted to prevent failures from calling outages. And this is obviously less urgent at lower percentages, not just because fewer customers would be inconvenienced by it, but because you still had the old search system around. We could switch people back if something did go badly wrong. This meant we had a safety net in the beginning. We didn't have to put in a lot of sort of resilience work. So the other thing was there were other systems around us that were running other parts of the website. So we felt that we didn't have to try to be... if there are other parts of the system that are going to take half an hour to an hour to come to restore in terms of disaster recovery, us taking working really, really hard to get ours down to 5 minutes isn't really going to help, because we had a search. If somebody else had the product page and the home page and the basket, and they were going to take much longer to come back than we will. We knew we didn't really have to try super hard there to be really quick there. So the other things we were doing were using multi-region cloud resources, so databases and topics, subtopics that were automatically multi-region. So that was basically free resilience. And we had this, because we had our own Elasticsearch, which was externally hosted, as I mentioned before. We were in a position where this was outside of the rest of the platform. So we had to put a bit of extra work into that, because that was our responsibility. The platform team weren't going to do anything with that. And we had a sort of a manual failover thing. We had 2 instances. You could change URL somewhere, and it would point to the other one. It sounded kind of simple. We were happy with this to start with. And then at some point, quite early on, we did actually run through the process of doing the switchover. And while it worked, the developers who did it were running through the steps, and they were, yeah, it works. I don't really want to be doing this at 3 a.m. If I get called out. So then we started to look at, yes, we do want to have some automatic failover here. So we put in some work. We put in a very sort of simple load balancing scenario. And this bit at the bottom I've put in, this is DR versus DA. A lot of the talk was about disaster recovery. If something goes down, we need to recover it. I started coming up with the word called disaster avoidance. If you avoid it in the first place, you don't have to recover from it. So this sort of automatic failover, load balancing between the 2 systems was meant to sort of remedy that. We didn't have to have much of a plan there. The 2 things were live the whole time, and could support our load on only one of them. So I think the sort of incremental journey here was we were going up through small percentages. We were happy at not being sort of fully able to fail over really quickly, because other parts of the system were not. And so I've got one of these diagrams again. We've got in grey brackets ×2 on the index and search API, because they were part of the platform that the platform team would back up and restore for us in case of a disaster on the platform. And so that's why it's kind of, they're in brackets, they're kind of grayed out. They're like a ghost ×2. The search engine in the middle, we genuinely had a ×2 on there. We maintained that. So again, what didn't we do? I mentioned we didn't put in automatic failover initially. We didn't think it was important. I think this is something we had to kind of hold ourselves back from. It's like, oh, this is really, really cool. It's really cool. We want to have all this stuff happening automatically. But we knew it wasn't important enough in the beginning. And we didn't add a lot of sort of custom failover stuff as well. We relied on cloud provider resources being available. We trusted their SLAs basically, and things that were on the things the platform team were maintaining. We relied on them to deal with that. So Again, from a sort of geeky point of view, it's like, oh, we can have all this kind of balancing and automatic failover and stuff. It's like, no, step back. We put something in later on, as I mentioned, but to start with, we were quite sensible, I think. So I come to something, alerts and runbooks, which these seem sort of more offline or analog, particularly runbooks, than all the other stuff I've spoken about. I used to really despise runbooks. Runbooks were another one of those things which, in old days, if you're handing over to an operations team, somebody eventually would come to you and say, "Hi, you're going to go live next week, aren't you? Yes, we need a runbook from you." And they might give you a vague idea of what they wanted, or they might give you a big, long checklist of what they wanted. Either way, you were kind of huffily bashing out runbooks documentation at the last minute and hating it. But working in a build it, run it team, I've actually quite grown to like runbooks, particularly because you feel like you're doing it for your own purposes. So if you're writing a runbook for your own use, you can tailor it to be for you, and you can even just run through the scenarios yourself to make sure they make sense. In our so this is across a load of teams actually that these things came up. Again, you can build up. Having a runbook is a very valuable resource, but it can feel kind of daunting as like, oh, we're going to need a huge amount of documentation for this. You can build this up. You can build this up piecemeal. So one of the best things we found was we would do it through the fact that we needed alerts. So we want to alert on symptoms, like if the latency is too high or there are too many errors, alert on that. And then the alert can link to the runbook. The runbook can list potential impact on customers and a list of things to investigate to find the cause. And it can link off to logs and dashboards and maybe further documentation. So if you think, oh, we need an alert because stuff is slow, then write a page in the runbook for that alert. And what are the remediation things? Oh, are we going to need to scale up if it's because the CPU is being used? Okay, in which case, let's write that page. So you can build up the runbook piecemeal like this as well. And actually, I've really started to like runbooks. You know, you kind of feel, if I'm going to be paged at 3 a.m. and have to bleary-eyed figure what was wrong, it's nice to have that list. And I think if you're doing it for your own purposes, you aiming it at your own level as well. The people in the team, in the build it, run it team, are the same people who are going to be supporting it. So the people in the team know what they know and can write it in their own language. So I do this little quite simple diagram. It's like, if you have your alert pointing at the runbook points at your logs and your dashboard, great. You can click through, you can see everything. You don't have to try to remember what the URL for your dashboards are, that kind of thing. But the dark blue ones are all part of your runbook, and you'll have a runbook index. It will point at all the pages for various things. And the sort of common processes and things to fix, some of these will be driven out by that as well. Like, for example, if you want to scale up, your system will scale it down, or I don't know what else, something like we need to rotate a password or something because it's been leaked or something. All those things can go in common processes, and knowing that you're going to get alerted for something and knowing that you're going to need to remediate something at some point can really drive you to put those things into the runbook. So I've got through that a lot more quickly than I thought I would, actually. So in summary, I've put this kind of thing into practice. Prioritize and understand what you need to do right now to support your current usage. And I think it's important to get something in early on and know you can build on it. So it really helps to have a single backlog here and a product owner who is happy to prioritize this kind of work against, oh, we need some new functionality. Quantify, if you can work out the value of a certain amount of downtime. In something like a retail website, it's relatively easy to work out at this time of day, if I'm down for an hour, how much they're going to cost. And then that allows you to weigh up the value of putting in some resilience work versus adding any new features. And the requirements do change. It's really worth knowing what's on your backlog and what's coming up next as a developer or a QA in the team. And that means you can have a very good dialogue with your product owner about the relative priorities of these things. And so make all of this stuff just business as usual. So if you start small, hopefully it was, I think I skipped over some of these things too quickly, but hopefully it was obvious that in all these cases, these are things that are very useful to have, but if you start small, you can just keep adding to them. And if you start small and they're embedded in the way you work and everything you do, every new feature, you add some more metrics and you write a runbook page with the things that could go wrong about it, and you make sure it's scalable and you consider your resilience. You never have to go to your product owner and say, oh, by the way, we need 2 months off because we need to fix the performance. Performance is rubbish. We can't go live like this. So if you put those things in early, you never have to make a big case for going back and arguing to put it in. You never have to retrofit it. And also, hope you never in that position where you do get stuck last minute. Oh no, actually, we need to write a whole new performance test. We do need to, spend a week writing runbooks because we don't have one. So yeah, I think that was it. Yeah, thank you very much. I said, yes, I think I galloped through that really quickly. So if there are any questions, we do have some time. If you'd like to ask any, otherwise, yeah.
Thank you. Hello.
Hi.
So I'm going to be greedy. I've got a 3-part question.
Go for it.
You mentioned being able to kind of move customers from old search to new search.
Yeah.
Which implies there was something in place already. So first of all, it'd be interesting to know why you had to build the new search. Then second of all, you talked about going from 1% to 100% over 9 months. And again, interesting to know why that took so long. And finally, you mentioned Black Friday a lot. And it'd be interesting to know if you had anything in place for predictable spikes in terms of scaling.
Cool, yeah, thanks. So, sorry, what was the first one? Yes, it was part of a larger replatforming project, which was moving a lot of different things over to a new platform. It was something that was strategically planned for a while, and the search was one of the first parts of it to be moved. The thing about the percentage was, so this is the bit about our product owner was very good at the functional side of this. He was, okay, we can go to a small percentage of customers with just search, no fancy sort orders. We're not going to have, a lot of filters or banners and stuff. 1% of customers can put up with that, pretty sure. So throughout the rest of the time, what we were doing was adding more functionality and tuning the search. So it wasn't necessarily the case of, we're going to take 9 months to get more capacity and work out how we're going to scale the thing. It was more about, there were a whole bunch of missing features that we had to add. So things like, I didn't actually talk much about search versus browse here. Search on websites, often when people are typing something into a box and hitting enter and searching for words. Browsing is when you would go down through a hierarchy of categories and brands and things like that. So initially we only had search. We had to add browse as well. And then we had other things like type ahead suggestions and things like that, which came later. So there was quite a big backlog of functional stuff we had to get in before we could actually go to 100% of customers. And it was convenient as well, from a point of view of learning the system. When we went to 100%, we'd already been live for 9 months, and we'd been incrementally adding. When we got to 50%, that's when we thought, oh, now we need to be on call. So that's when all the alert stuff came out and that kind of thing. So it was a nice sort of, I wouldn't say gentle rollout. It was pretty brutal at times, but it was useful. And sorry, there was a third part, wasn't there? Yes. So Black Friday is quite a predictable spike. There are kind of two spikes in a way. There's the launch of Black Friday itself, and there might be other sort of specials. Because I think Black Friday being one day, I think is a thing of the past now. It's like a Black Friday week now, really, isn't it? So that's something we did test for. We expect this much traffic, we're going to add on a certain percentage and test for that. So there was a predictable spike, and we could scale up to a certain degree and just leave it there for a few days and then scale it down to sort of intermediate level. It's just scaling up and leaving it, enormously scaled up at Black Friday level for a long time is relatively expensive infrastructure-wise, but it wasn't too difficult to actually do technically. Did that answer the questions? Yeah, thank you. Sorry, there for you.
So, Stephen, you talked about the idea of being able to sort of ramp up traffic onto this new search, and also the idea about being able to release multiple times a day. And you also talked about, I think in both your examples, about there were like one or possibly in each example, it was like there was one key metric that was like really important. I was just wondering, would only one metric have been enough to go live?
No. I think there were certain metrics that were very important to us. I think the ramp up of amount of traffic coming in, as I said, was mostly geared towards the amount of functionality we'd had, and sort of now this tranche of customers can come along because we've added this particular piece of functionality for this type of page. In most of those cases, the sort of metrics we've talked about here were, have we broken the latency? As it got slower, as we've added more people, have we added more errors coming through in the availability? One of the main metrics for working out, which I haven't actually mentioned, is separate to all of this, was number of people adding things to basket, number of I've forgotten what the amount of money people were making on the website. So if we switched over something and actually you search for socks and you get wall mirrors or something, that's obviously an extreme example, but there were a lot of these subtle things which took a long time to tune, and we would get a lot of that from analytics, which were gathered by another team, sort of sales analytics. So that would guide a lot of the rollout process. Whereas most of the stuff I've put here was more sort of from the team looking inwards and thinking, if something goes wrong, how are we going to know something's gone wrong technically with our service, and how are we going to remediate it if that has happened, which is kind of, I don't really want to say it's separate from, because we exist in order to sell things. It's a holistic service. It takes all these things into account. But yeah, you're right. I didn't touch on those things. I think, and they were very important in our journey.
I think we're out of time. Well, we're out of time for questions. Are you going to the boat party?
Yes, I'll be at the boat party.
So if you go to the boat party, you can ask him loads of questions there. I hadn't thought about MVP for operability before, so you could be like great new ideas. Thank you so much. Can everyone give him a hand?
Thank you.